The comet Shoemaker-Levy created the largest fireball ever observed when it collided with the planet Jupiter. The explosion had been observed with considerable interest by another scientist too, John Wasson, one of the world's top meteorite experts from UCLA. He had also been curious about the origin of the Egyptian desert glass, looking in particular at one special piece of the glass.
It's special because it has very distinct layers. The layers consist of dense glass, which is almost free of bubbles, and foamy glass, which is full of tiny little bubbles.
Wasson believes the layers were formed by intense heat radiating from above, from an extremely hot sky, and he remembered the explosion over Tunguska.
When the thought came to me that it required a hot sky, I thought immediately of the Tunguska event. That's exactly the kind of event that I need. An aerial burst, but many, many times larger than Tunguska. Perhaps 1,000 times or even more times larger.
And the massive fireball produced on Jupiter by the comet Shoemaker-Levy seemed to offer a possible explanation.
I thought, how nice. The Shoemaker-Levy comet seemed to me to be ideal for producing an aerial burst and producing desert glass.
It set both Wasson and Boslow thinking. Could a similar aerial burst happen here on Earth? To take this idea further, Boslow needed to adapt his computer model to simulate an aerial explosion, and for that, he needed more data. He wanted to see for himself how widely the glass was spread in the desert.
I think it's helped a lot to see the distribution of the glass, how widespread it is in some places, how concentrated it is in others.
Scientific papers say the glass is scattered over 6,500 square kilometers of the desert. Boslow doubts that the original area could have been that big.
Well, it's not clear to me whether the current distribution was the actual distribution when the event occurred.
The Sahara only started to become a desert about 7,000 years ago, and during the last 30 million years, there have been big rivers and lakes here.
What I think is that the glass was originally at a much smaller area. There were lakes here some time ago and there was some water, and it transported the glass farther away from the area where it originated.
Boslow was now confident that 30 million years ago, the distribution of the glass in Egypt was smaller than now, but it still needed a massive event to produce it. He fed the latest data into his computer model.
What we modeled is 120 meter diameter object entering the atmosphere at 20 kilometers per second, and we started off the simulation way above where this frame starts.
To explain the evidence of an actual impact found in the desert, the simulation allows a fragment of the meteorite to reach the ground and make a small crater. But such a small impact would not produce the glass. The simulation also shows something far more powerful is happening at the same time. Before reaching the ground, the incoming meteorite is burning up, leaving a trail of incandescent material in its wake. A massive column of fire, which turns into a fireball.
The widest temperature here is the temperature of the surface of the sun. And as it expands, the fireball is actually pinned against the surface, and it's moving very rapidly beyond hurricane force. So we've got this blast of air that's hotter than the melting temperature of the sand blowing across the sand, so it's melting the top surface, and then that melt freezes to form the glass.
And just as on Jupiter, an enormous plume of searing gas is streaming out into space.
So while all this material is creating this fireball down on the ground level, there's also a plume that's being formed at much higher altitudes, 80 to 100 kilometers above this level, and it's ejecting material out into space.
The simulation shows that even a relatively small meteorite can create a fireball hot enough to produce the mass of glass in the Egyptian desert. The explosion dwarfs the first atomic bomb blast at Trinity.
What I want to emphasize is that it's hugely bigger in energy, hugely more powerful than the atomic test at Trinity, 10,000 times more powerful.